Welcome back to another lesson in MCR3U. Today we'll be looking at transformations of quadratics. So when we look at the transformation of quadratics, the first thing we have to look at is what is called the parent or base function. The parent or base function are the simplest functions in a family. So the simplest functions in a family. And a family means a group of function that has similar characteristics. In terms of quadratic functions, the parent function is f of x is equal to x squared, or y is equal to x squared. When you transform a quadratic, your equation must be in vertex form, as we've looked at previously, which is f of x is equal to a x minus h squared plus k. And so the first thing that we're looking at is vertical translations. And vertical translations occur outside of the function. Vertical translations will impact the y value of the function. So it impacts the y value of a function. So here, if we look at this, it looks at the parent function, and then we're going to look at the mapping notation for each of these transform functions. So here, if we write the parent function, we write as y is equal to x squared. And here we'll create a table of values for the parent function. So here, if we look at the x and y values in terms of y is equal to x squared, sub in -1, it gives us 1. If we sub in 0, it gives us 0. And here, if we sub in 1, it gives us 1. Here, in terms of the second transform function, we get f of x is equal to x squared plus 2. So here, when we write our mapping notation, we start with the points x, y from the parent function, and then we write the new points based off of the transform function. So here, the x values will stay the same from the original parent function, but the y values here we see are impacted and moved up by 2. So again, the x and y would be our parent function, and our x and y plus 2 is from our transform function. So here, if we draw our table of values again, you see that our x values have stayed the same, so they'll still be -1, 0, and 1. But for all of our y values, we're going to add 2 to them. So here it becomes 3, 2, and 3. Okay, so let's look at this next one here. The next one here, it's f of x is equal to x squared minus 1. So again, we have our original function and our points x, y. And here we look at the transform function. The x value stays the same, but here the y value goes down by 1, which is seen as y minus 1. So here, if we put in our table of values, again, our x values stay the same and our y values will decrease by 1. So here, our x values stay the same, -1, 0, and 1. And our y values here will then become 0, -1, and 0. So here, when we look at our translations, if the k value here is positive, we know that it is translated whatever the units are, units up. So if it's positive, it's translated blank units up, depending on what the number is. If it's negative, it's translated so here it's translated blank units down. Okay, so here, next we'll look at horizontal translations. And so vertical translations impacts the y value of the function, and the horizontal translations impacts the x value of a function. And so here we have our horizontal translations, and our parent function stays the same. So again, our parent function is still y is equal to x squared. And our parent function doesn't change. So here we have our xy values, and we have -1, 0, and 1. And for our y values, we have 1, 0, and 1. Here, when we're looking at our mapping notation in terms of our transform function, we have f of x is equal to x minus 3 squared. So again, we start with our parent function, our xy values. And here, again, the x values will get impacted. And here, it's opposite of what the sign is inside the bracket. So here, inside brackets, x minus 3, our transformation will be x plus 3, and our y value stays the same. And so here, we have our table of values. Now, all of our x values are added by 3. So from -1 becomes 2, and then 3, and then our y values here will stay the same. So it will be 1, 0, and 1. Here, our next transform function is f of x is equal to x plus 4 squared. And so here, if we have our original parent function xy, here it gets transformed. And so again, the opposite from what's inside the bracket. So here it'll be x minus 4, and then y values. Okay, so here we have our x and our y. And so here our x values are decreased by 4. So here we get -5, -4, and -3. Our y values stay the same. So 1, 0, and 1. And so when we look at our translations here, if it's positive, here we see that it's translated blank units to the right. But here, when we look at it inside the brackets, we see that it would look like x minus h. Here, if the value is negative, it's translated blank units to the left. However, inside the brackets, it would look like x plus h. And so it's always the opposite of inside the brackets, because when we look at vertex form, it's written as x minus h squared. Okay, the next thing we'll look at here is vertical reflections. And so the vertical reflections are, again, outside of the function, and these will impact the y values again. So impact y value of function. And so here we have f of x is equal to x squared, that's the parent function. And if we have f of x is equal to -x squared, So again, the parent function, y is equal to x squared. We have -1, 0, and 1. And here, if we look at our transform function, it impacts the y values. So if we look at our mapping notation, it goes from x, y, and it impacts our y value with a reflection. So here it'll be x and -y. So all our y values will be negative. So here we have -1, 0, and 1 for x values. Those stay the same. But our y values are all negative. So it becomes -1, 0, and -1. Next, we're going to look at vertical stretches. So vertical stretches are, again, will impact, again, the y values here. So vertical stretches will impact the y values of a function. Okay, and here, if we compare again the functions, again, in the parent function of y is equal to x squared, and f of x is equal to ax squared. So here, if we draw our parent function, again, that's f of x is equal to x squared. We draw our table of values. And same thing as we've done previously. Here, when we look at f of x is equal to 2x squared, it's going to go from the original parent function. And here, the x values still stay the same, but for the y values, they'll be multiplied by whatever the a value is. So here in this situation, it's 2. So we look at our table of values. X values stay the same, but our y values be multiplied by 2. Same thing here with f of x is equal to 1/2 x squared. So our x, y values will stay the same in terms of the parent function, and our transformed function can multiply the a value to y. And so here, its values stay the same. Y values be multiplied by the a value. So here we'll get 1/2, 0, and 1/2. Okay. So here, this example says list the transformations in the correct order for the function f of x is equal to -1/2 x plus 2 squared plus 1. Okay, so when we list the transformations, it's always going to be first, it's going to be any reflections that occur. So first, reflections. Second will be any stretches or compressions that occur. And third, and third are translations. So translations are always last when we're listing the transformations. Okay, so let's take a look at this. So here, what we can see if we write our reflections to start, so we see that there is a reflection across the x-axis. That's from the negative in front of the 1/2. And from the 1/2, we can see that there's a stretch by a factor of 1/2. Then we look at our translations. We see that it is translated, the transform function is translated So here we see that it's translated 2 units to the left, and it's also translated 1 unit up. Okay, so here we see again our transformations, our reflection across the x-axis stretched by a factor of 1 over 2, translated 2 units to the left, and translated 1 unit up. So here, again, our parent function and our x and y values. In our mapping notation, so here, again, we understand the transformations here. The x values are only affected by whatever the h values are, but for the y values, they're affected by the a, whatever the a value is, and the k value. So we can write it like this. So we can write it as x plus h, ay plus k. That's the transformations that again affect the x values and the y values. So here, our parent function is x and y. In terms of our mapping notation, again, this is our mapping notation here, and we're going to list our transform function and the transformations that affect the x and the y value. So here, the h value in this situation is going to be -2, so x minus 2. Our a value here is -1 over 2, and our k value here is 1. So x minus 2 and -1/2 y plus 1. And so here, when we look at our table values, again, we're going to start with 0, 0, which is the vertex in the middle, and then we'll go down by 2, so -1, -2, and then we'll go up by 2, 1 and 2. And those values will give us 4, 1, 1, and 4 in terms of our parent function. And here in our transform function, again, we'll write it as we did in the mapping notation, so x minus 2 and -1 over 2 y plus 1. And so here, we're going to subtract all of our x values by 2. So we have -4, -3, -2, -1, and 0. And for our y values, we'll multiply by -1/2, and we will add that by 1. So here, we're going to get -1, 1 over 2, 1, 1 over 2, and -1. Again, one unique feature about the quadratics is it is symmetrical on both sides of the vertex. So here we see that our vertex from our parent function was 0, 0. And so here, when we look at our transform function, our vertex will be -2 and 1. So here we can graph this here. So here we'll first graph our parent function, which will be 0, 0, 1, 1, and -1 and 1, and 2 and 4, and -2 and 4. So this is our parent function. Y is equal to x squared. And then we'll look at our transform function. So we have -4 and -1, -3 and 1/2, -2 and 1, which is our vertex here, -1 and 1/2, and then 0 and -1. And so here it will be opening down, which makes sense because our a value is negative. And there'll be a few stretches and also some translations. So let's look at this too. So it says graph the transform function from f of x is equal to x squared if it is reflected in the x-axis, stretched by a factor of 2 and translated down 1, determine the equation of the transform function. Okay, so the parent function, again, stays the same as before. X and y values for y is equal to x squared. Here, in terms of our mapping notation, there's nothing in our transformations that affect the x values, but for the y values, because that's reflected in the x-axis, that means that you have negative, stretched by a factor of 2, so negative 2y, and translated 1 unit down. So here, our parent function values stay the same, negative 2, negative 1, 0, 1, and 2. For y values 4, 1, 0, 1, and 4. For mapping notation, our x values will stay the same. So here, they don't change. And for our y values, here we see, again, that it's negative 2y minus 1. So here we have negative 2, negative 1, 0, 1, and 2. And for our y values, we'll multiply by negative 2 and then minus 1. So here we'll get negative 9, negative 3, negative 1, negative 3, and negative 9. So here we can graph this. Again, we'll graph our original parent function here. Graph our original parent function. And then our transform function, we don't have quite enough space to graph the negative 2, negative 9 on the graph, but we can graph the other points. So we have negative 1, negative 3, 0, negative 1, 1, and negative 3. So it'll look something like this, and you can just extend it down here. So when we look at our transformed equation, look at f of x is equal to negative 2x squared minus 1.